Okay, so we're going to go into 0.3, which talks about polynomials. The first thing we want to talk about is what is a polynomial. So a polynomial is a an algebraic expression and it has a certain form. It has a certain degree, a leading coefficient, and a constant term. But it's an expression with terms split by adding or subtracting. So one of the forms looks like this. Okay, so it's just a series of terms is all it is. We have some special ones that we call a monomial. We have a binomial. Trinomial. Okay, and those are the three main ones that I will look at. So an example of a monomial would be like 8x squared. A binomial may be 2x plus 1. And a trinomial might be x squared plus 3x minus 6. Okay, so those are the three main that we're going to look at. And let's talk about how to write them. So we want standard form. That's how we want to write them, and that is from greatest exponent to least. Okay, so notice this trinomial right here has an exponent of 2, 1, and then 0. Okay, and we have what's called degree. Okay, the degree is the highest exponent. Okay. One thing I would like to add is that most often when we deal with polynomials, it'll only have one letter in it. It just doesn't necessarily need to, but we only like to deal with polynomials that do only have one letter. We could put like a y in each one of those as well to make a polynomial. But okay, so highest degree to lowest degree is standard form, and the degree is your highest exponent. So like this has degree 2, this one has a degree of 1, and this one has a degree of 2. And we also have the leading coefficients, which is is the coefficient of the term with the highest degree, or of the highest exponent. So this has the leading coefficient of 2, or of 1, of 2, and of 8. So if we write something, say we write a problem kind of out of order, let's say we have negative 3x plus 4x to the third minus 5 plus 2x squared. Okay, that is out of order, so we want to write it in the correct order, which is highest exponent. Okay, so this actually has a degree of 3, has a leading coefficient of 4, and this number out here without the variable, we call that our constant term. We can do some operations with polynomials. So the first thing we want to look at is adding. So if I want to add two polynomials, let's just say I'll do simple examples in this first video. Okay, and we're adding those together. So there are two polynomials that we're going to add together. I can just get rid of the parentheses, and because really I'm going to distribute a positive 1, so this becomes x plus 1 plus 2x plus 2. And I'm going to combine like terms. So the x's match up, giving me 3x, and my 1 and my 2 match up as my constant term. Okay, and then this is the same concept with subtraction. So if I just look at the same example here with subtraction, it's the same. Okay, but the only difference is instead of distributing a positive 1, we're actually going to distribute a negative 1, so it changes the signs in all of these afterwards. Okay, so then we combine like terms. So I get minus x minus 1 in this case. Okay, now what makes like terms? Like terms have the same letters and exponents. Okay, meaning if one has an x to the second, the other one has an x to the third, they will not be the same. Okay, so you got to make sure all their letters and the exponents on the letters are identical. Okay, we can multiply polynomials, and we do that by distributing. Again, I probably spelled that wrong. That's okay. So if we are multiplying, and a lot of you wanted to do this in chapter 2, 0.2 with just all the multiplication stuff. But if I have this, okay, and we are multiplying this out, we're going, okay, so this first x here goes into both of those. So we have x squared minus x, and then this 2 is going to go into both of those. So plus 2x minus 2. And then again, we combine like terms if we can for our final answer. Okay, I will show you another method of doing this that is easier with bigger polynomials. So let's say we have two 3-degree polynomials and we got to multiply those together. I will show you a better method than this one. This one is called FOIL, for first, outside, inside, last. And I will show you a stacking method of doing the same thing in class. Special cases, multiplying polynomials. And the first case is called your difference of squares, or difference of two squares. Okay. And that would be, you have a plus b times a minus b is a squared minus b squared. Okay, that is one of your special cases. And then we have what's called perfect squares. Okay, and I don't get into perfect squares all that much because you really have to know about perfect squares, and you don't necessarily have to know the concept of multiplying. And I like the concept of multiplying much better. So that would be something like a plus b squared, or a minus b quantity squared. So that would be a squared plus 2ab plus b squared. And this is a squared minus 2ab plus b squared. Okay, so you might note those. We'll talk about them a little bit in class. But again, I like this one. It makes you not have to know what an exponent is. And I really would like for you to know what an exponent does and is. And there's two more. They're called difference of cubes. Okay, so difference of cubes. There's two of them. Well, there's one difference of cubes, and then we have sum of cubes. Okay, and those look like if we have sum is a plus b to the third. This one is a minus b to the third. So a minus b to the third would be a to the third minus 3a squared b plus 3ab squared minus b to the third. And then the sum is the same pattern except it's all positive. ab squared plus b to the third. Again, I don't care if you don't know these, okay? We will be able to do all of this without formulas. That's my goal. We got to be able to do anything without formulas. Okay, so that is kind of the start of 0.3. I have your questions here. So the first question is, what's the difference of squares formula? That's probably the most important one there. What is a polynomial? And then expand that problem right there. Here are your suggested problems. Please write those down so that you have them in class if we have time to work on them. Again, if you are going to be here in class, now is your stopping point. Be in class, continue on watching. For those of you leaving, this is at THS, Mr. Jones signing off. All right, for those of you remaining, we're just going to look at some quick examples here. So let's start with this one. This is 3x squared minus 8 plus 14x third minus 20x to the 8th plus x. So I first want to write it in standard form. That is highest exponent to lowest. So it's minus 20x to the 8th plus 14x to the third plus 3x squared plus x minus 8. So this is degree 8 because that is my highest exponent. It has a leading coefficient of minus 20 and a constant of negative 8. Because there are 5 terms, this is a 5-term polynomial. Okay, there we don't have a special name for it. Okay, so then we went on to adding polynomials. 5x squared minus 2x plus 3 plus 3x to the third minus 4x squared plus 7. Okay, if I go to distribute the positive, nothing changes. Okay, so we could drop the parentheses, but I just like to look at it like this. So my highest exponent is x to the third. Do I have anything else to add to x to the third? The answer is no. That one goes away. We have x squared. We have 5x squared plus negative 4x squared, which would be a positive x squared. So I mark those out. 2x plus, and there's no x's over there, so that one stays. We have 3 plus 7 is 10. Okay, so there's our addition with that one. We can do subtraction like very similar to that. Okay, so in this case, I'm going to distribute that negative into everything after. So this is 3x to the third minus 2x plus 1 minus x squared minus 5x plus 9. Okay, so now I just combine like terms. There's no more x to the thirds. I only have this x squared. I have negative 2 minus 5x, so that's minus 7x. And I have 1 plus 9 is 10. Okay. So it's all about combining like terms, distributing that negative and combining like terms. Now we have multiplication, which is, some would say the difficult one is multiplication. So let's look at 5x squared, 3x to the 5th minus x to the 3rd plus 7x minus 4. Okay, now here I just have a monomial times a bigger polynomial. So we're just going to take this on the outside and distribute it into all 4 terms there. So I have 5 times 3 is 15. And x to the 5th, which makes x to the 7th. Okay, I have 5 times negative 1, that's minus 5. X to the 5th, remember we're adding the exponents here. Plus 35x to the 3rd minus 20x squared. Again, just double check to make sure you don't have any like terms to combine, and then circle your answer. Now with some that are a little more difficult, okay, we have this one here. Okay, and I can spend time and distribute this 2x squared to all 3 of these. Okay, but I don't want to do that. I'm going to try to make it a little bit easier. Okay, and we're going to multiply. If I was to multiply these 2 numbers together, kind of back in middle school or elementary grades, you would take the 3 times the 5, 3 times the 1, 3 times the 1, then go to your next line, put a 0, and then continue on through that. We're going to do that same concept here with this one. So we're going to take this and stack it underneath. The reason I like this is because it keeps you very organized. And we like to circle our operations, that way we don't misinterpret it for an x. Okay, so now we're going to start here, and we'll take 7 times 1 times negative 3x, which is minus 21x. 2x squared is 14x squared. We will put a placeholder, and we will come here. So negative 5x times 1, negative 5x. Negative 5x times negative 3x is negative 15x squared. Negative 5x times 2x squared is negative 10x third. Then you put 2 zeros. Now I'm going to run out of room here. Put 2 zeros. And we'll go x squared times 1, x squared times negative 3x, and x squared times 2x squared, so it's 2x to the 4th. Now, when you add down, you should notice that all your like terms are already there for you. So this is a plus 7. This would be a minus 26x. This would be a 0. Okay, you got 14 minus 15 is negative 1 plus 1 is 0. So we don't even have to put that one in there. Okay, then you have negative 10 minus 3, that's minus 13x to the 3rd. And then we have 2x to the 4th. Okay, so I really like that, especially for much larger polynomials when you multiply those out. You can go on a simple route too. We can check out 3x plus 1, 2x minus 5. We could stack that just like we did that one, or we could do simple FOIL. So that's 3x times 2x is 6x squared. 3x times negative 5 is minus 15x. 1 times 2x, 1 times negative 5, and then again we look for like terms. So it's 6x squared. Minus 13x minus 5. Okay, so that is multiplying, and again, they can be of any size that you want there. And let's talk about in the first part we talked about some special cases. something like x minus 5, x plus 5. Again, we don't have to get bogged down in special cases. Simply take this and FOIL it out. So you have x squared minus 5x plus 5x minus 25. Well, know that those cancel out. Negative 5 plus 5 is 0. So then you just have x squared minus 25. Okay, so you don't need to know really that formula. And then we have something like this, x minus 5 squared. Know what an exponent is. That is telling you to take this base times itself. Okay, and then FOIL it out. Leave x squared minus 5x minus 5x plus 25. So it's x squared minus 10x plus 25. And you're done. Okay, so please know how to multiply and what the exponents are telling you. Let's try maybe a harder one here. Find some paper. Okay, so let's look at x plus 2 to the third. Okay, that's telling you to take this base 3 times. So it's x plus 1, sorry, x plus 2, x plus 2. Okay, I got 3 of them. Just take 2 of them and FOIL them out. So you got x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Now, you still have this one back here. So now we're going to take this times this one. So you got x times x, or sorry, x times x squared, x to the third, then plus 4x squared, plus 4x, then go to this one, 2x squared, so that one, plus 8x, plus 8. Now we got to look for like terms. I don't have another x to the third. I have, looks like 6x squared, 12x plus 8. Okay, and you're done. Okay, you need to know how to expand out knowing the formula. Okay, we could have something like this. This would be the last one I do here. I like it because it has more than one letter. Okay, so this is telling you that you're going to take this times itself twice and FOIL. You get 2x times 2x, that's 4x squared. You have 2x times negative 3y, it's minus 6xy. You have negative 3y times 2y, that is negative 6xy. And the order of these letters does not matter. So then you have plus 9y squared. Still have like terms, so you have 4x squared minus 12xy plus 9y squared. And you are finished. Okay. Again, here are your questions from the first section, and also your suggested problems, with 83 being your challenge problem. Thank you for watching. If you come up with some questions, please let me know in class. I'm happy to help you work any of these problems out. If you're not following me on Twitter, please do so. It's at THS Mr. Jones. You'll find all your updates on class there. And thank you for watching.